Here's pre-calc part 2 of your lecture for 10.1.4. We're going to do problem 10-70. This is the part where they wanted you to derive the equation of a parabola. It says, now you will use your understanding of the definition of a parabola to write its general equation. Label your parabola as shown in the diagram at right. So I'm just going to show you the diagram. So letter A, it says mark a point on your parabola P. It can be any point on the curve, and label the coordinates x, y, and then draw a segment from P to the focus and write an expression for the distance from point P to the focus of your parabola. So anywhere on the parabola, I chose this little point right here, and I called it x, y like they told me to. And I'm supposed to draw a line from my point P to my focus. And then it says write an expression for the distance from point P to the focus of my parabola. And you can see what they got, but where did they get it? So if you already know the distance formula, and if you accept that and understand it, you can just always just use the distance formula. The distance formula between 2 points is the difference between the y's squared plus the difference between the x's squared. It doesn't matter if you put the x's first and the y's second because they're getting added. And take the square root of that. That's the distance formula. If you don't understand the distance formula, you can think of it as a triangle and think about Pythagorean theorem, because that's where the distance formula came from. So this is the side of a triangle, like, a squared, b squared, and then this hypotenuse is c squared. So I can figure out this length by subtracting the y's from each other. This is y2, or, well, let's just call this y2, and that can be y1. So that's where the y minus c comes from. It's this distance right here. And the x squared comes from this distance because it's x2 minus x1. Well, x minus 0 is just x, and so that's this. And then we're using Pythagorean theorem, so we're going to square this side. So that's where the squared came from. We're going to square this. Remember, we said it was x. And that equals c squared. But then we got to square root both sides, so we get this. So you're going to see these in your homework. So just think of Pythagorean theorem, or if you know the distance formula, just think about the distance formula. That's an expression for this distance right here. And then letter B wants you to write an expression for the distance from point P to the focus. Oh, draw another segment from point P perpendicular. Oh, okay, here it is. Perpendicular to the directrix. Write an expression for the distance from point P to the focus of your parabola. I think they want this. So I think they meant the point of my parabola. So this and this have to be equal for it to be a parabola. The distance between the focus and the directrix, it has to be the same. So from to the point. So this, I don't know if you can just tell, it's y plus c, because if this is negative c, like from here to here, then this little extra bit of height, that's y. So it's y plus c. Okay, and then so we're going to set these equal to each other because that's the definition of a parabola, is that this line, this length and this length are supposed to be equal. So it says, what is the relationship between these two distances for a parabola? We're supposed to know that they are equal. Use this relationship to write an equation for your parabola and simplify your equation and solve it for y. Okay, so this thing, to simplify it, I'm actually just going to show. Hold on a second. I'm going to show this right here. So this is what we had. This distance, this is this distance, and the y plus c, that's this distance. We know they're equal because that's the definition of a parabola. And then they wanted us to just do a bunch of algebra. So they squared both sides. That got rid of the square root. And then they squared this part out. That would be y squared minus 2yc plus c squared. If you square that little piece out, and the x squared just comes down. This part got squared out and turned into this. Now, I don't know if you can notice this right away, but this y squared and that y squared cancel out. These c squareds cancel out. So stuff was canceling out. I can get, what was I supposed to solve it for y, right? So I can add this to both sides and get that. And then I can divide both sides by 4c and get that. Okay, so that is just kind of a derivation of the equation of a parabola. So I just wanted to show you that because you're going to have those in your homework sometimes. Now, with the rest of the time that we have, I want to do 10.7.2. So can I write it in graphing form? So it says graphing form for a parabola where the vertex is at hk and the distance between the vertex is c unit, and the distance between the vertex is c units, is y minus k equals 1 over 4c times x minus h squared, or, so some of these, like this one would be an upward or downward facing parabola. This would be a sideways parabola. Work with your team to rewrite each equation below in graphing form. As you work, be sure to record your algebraic steps and think about your strategies. Be prepared to share them with the class. So on one like this, you just want to complete the square. We had a Zoom meeting today, and I actually feel pretty confident about you guys' ability to complete the square. I think I'll go ahead and just do one of these, though, just in case not everybody got it. So letter A, it wants me to turn this into graphing form. So I just wrote it down. That's graphing form, except for they like to put the y, they like to make it be y minus k. I always put the k over here because I think we were doing it like that before. So anyways, we're gonna, what we do here is, the way I do it, is I look at these two terms, and those are both the y terms, and I want to complete the square with those. So I factor out the 2, which gives me the y squared and the 6y, and then I don't know this number yet. This is like the number that I wish I knew. And then so I get the number that completes the square by taking half of 6 and squaring it. So half of 6 is 3, 3 squared is 9. That's the number right there that'll make this into a perfect square. But if I add that 9 inside the parentheses, what I'm really adding is 2 times 9. Because I put the 9 in the parentheses and the 2 is going to multiply it. So I have to add 2 times 9 to the right-hand side also, because I introduced this 9 here, which is really 18. I got to introduce the 18 over here. Oh, and by the way, these, I took them over to the other side of the equation, this little piece right here. Okay, so this came from, that's the perfect square. This came from, I just combined like terms, and I got that. And then I can just solve it for x by subtracting 1 on both sides. Or you can leave it like this, because they seem to like it that way. And then I wanted to know, why did I want to know what C was? They said, as you work, be sure, because later on they asked me to graph the parabola. So maybe I didn't need to know what C was yet, but now I do want to know what C is. So the way I do that is I see that this 2 is in the spot where A usually occupies. So that's A. So, and I know that A is equal to 1 over 4C. So, but A is 2. So 2 equals 1 over 4C, and so that's what I've got here. And then I find out that C is 1/8 just by doing algebra. And so then I'm not going to do the whole thing, so I'll run out of time, but I am, like letter B, you guys can try that one. But it says I'm supposed to graph it. So now that I have this thing in graphing form, I'm going to look at my shift. Oh, it's a sideways parabola, right? Because the y part is squared. So this y, so this shift is a downward shift because it's with y, not x. So it's down 3, and then this will be left by 1. Down 3, left 1. So I'm going to go down 3 and left 1. That's my vertex. And then I know that it's sideways just because the y squared is the one that, the y is the one being squared. And I actually know that it opens to the right because this is a positive. If it was a negative, it would open left. But I can't tell very easily. Like, I can tell that C is the focus. So I know the focus, the focal distance is like 1/8. Like, it's really small. There's a focus right in there somewhere. This little distance is supposed to be 1/8. I made it look more like a half, but there's the focus. And then I try to just plot a point. Like, I know the axis of symmetry is going to be right here. So if I just plot a point, I thought it would be very cool to just plug in, for y, plug in 0. And then I'd get 3 squared is 9 times 2 is 18 minus 1 is 17. And I was like, oh, 17. That is not very easy to. So now I know that way out here, I could actually just count by 2s or whatever, or count by 5s and scale my graph and show the 17 out here, but see how big these are? 17 would be way out here. So I decided not to graph that point. I decided instead to plug in a 0 for x. So if I plug in a 0 for x, then I could, add 1 to, oh wait, actually I did it right here. If I plug in a 0 for x, I can add 1 to both sides, and then I can divide both sides by 2, and I can square root both sides, and then I can subtract 3 from both sides, and I get that when x is 0, y is -3 plus or minus 0.7. And that makes sense because there's -3 plus or minus 0.7. So I know there's a point here and here. It's supposed to look like it's going through them. And then that's a good enough graph for you now, for now. I think later on we're going to learn about this thing called the lattice rectum, and then you'll be able to do more than just having to plot a couple points. But I think that's good enough.